Okay, good afternoon to everybody. And I'm Paolo Grati. We'd like just to briefly introduce the activity and in which way we decided to start this new Recarbon activity. The origin is a consultancy company that was involved some years ago from a big OEM, Italian OEM, to found a solution to use the scraps of the company. And we started this activity, I think, 5 years ago. And then we approached the problem. The problem is just a market situation. You have to consider that last year was produced more or less 110,000 tons of carbon fibers. Of all these carbon fibers, during the different processes, we have more or less 30,000 tons of scraps, vast material. And of this quantity, less than 10,000 tons was really recycled. This is the situation, international situation last year. In the meantime, we have a market situation in which you can see there is a continuous production of scraps, so vast, and that is until now was not so used, as mentioned before. You have a growing demand, a continuous growing demand, very fast, that is more than the growth in the carbon fiber production plants. And this is the situation for which is really important to find a solution for this application. And we start this activity, and we put on the same table a supply chain in order to create this clever system. And we decide to create this Recarbon company in which the activity is it's really to handle, to manage the complete system in order to give to the OEM or big players, etc., a possible solution, both with the thermoplastic or thermoset material. And now I pass the microphone to my colleague Patrick, that will present better the activity of Recarbon.
Nice to meet you, everybody. Patrick Pacchetti, and I'm the project manager of Recarbon. So thank Paolo for the introduction. So, of course, when we speak about recycled carbon fiber, we have to take in mind that the highlights, the advantages of this kind of fiber are related to the cost. So the cost effectiveness about with respect to the virgin carbon fiber. Of course, the material is versatile, because with the recycled carbon fiber, you can use the material in many applications. And of course, it's green, so more sustainable. And we will see later. So we provide a solution towards all these aspects. So price reduction, environmental impact, and weight savings, of course. This is a typical way of business for us. When we start from an initial request from the customers, we can say a linear, simple process from the component selection through the manufacturing, validation, qualification, etc., introduction in the line. Or we can also manage the waste chain, so we can close the loop by collecting the waste and also giving back the waste through different forms like thermoset and thermoplastic components, products, intermediates. This is our product line. So we space from the organosheets and sandwich panels and thermoplastics. And we also can provide the thermoset prepregs in collaboration with FiberTech Group. Starting from the thermosets, we have, I provide you some data, the important data related to the GWP, so the CO2, the emissions. When we speak about laminate, recycled carbon fiber laminate, like a T700, with respect to the virgin carbon fiber T700, we have immediately a reduction of 80% up to 80% in terms of CO2 because of the nature of the fiber itself, of course. Because when you produce the virgin carbon fiber, you have to reach more than 1,000 degrees Celsius. Instead, when you produce the recycled carbon fiber, also with pyrolysis, you have really lower temperature, like 400 degrees Celsius. And as we were speaking, of course, when we speak about both stiffness and stiffness and strength, specific stiffness and strength, we have at least the same or even better performances with respect with all the other materials like virgin glass fiber and aluminum, steel, metals, etc. Of course, we have a reduction with respect to the virgin carbon fiber for the nature itself of the material, the length of the fiber, which is a non-woven, actually. Some applications, some case studies, some customer, etc. Of course, we can disclose something. We can't disclose everything because, of course, we have NDAs, etc. So we space from the door molds, finishing components, etc., aesthetic components. In all this kind of application, we reduce the prices about 30% and 80% of LCA in terms of CO2 emissions. Then I would like to speak about the thermoplastics, which are actually our main business because we have our proprietary line, and this is what we really produce and manufacture directly. So we started with the organosheets, which are a class of material also known as LWRT, lightweight reinforced thermoplastics. So different kind of thermoplastic matrices like polypropylene, polyamide, etc. Generally mainly for the automotive application. This kind of material has a particular behavior which is related to the grade of consolidation. They have both the density and the mechanical properties related to the consolidation grade. They have air inside, as you can see, so they change their density. Here you have some data. It's not. As you can see, with the green line are related to our material, and the red one are the reference material, which is actually glass polypropylene. Our is recycled carbon fiber polypropylene. As you can see, we can see quality of the line of the curves are similar. So we have the same behavior about the two. This is the bending modulus. So the more consolidated is the material, the higher are the performances. On the other hand, the less is consolidated the materials, the more is stiff the material itself. It behaves like a sandwich panel, we can say. As you can see, qualitatively, the curves are the same. There is just a shift in terms of 4 or 5 times. So this allows you to scenario. We can have more performances, of course, with the same weight and thicknesses, or, which is better normally for the automotive, less weight with the same performances, or also both in terms of combination of these two scenarios. So we have, of course, we can disclose with which OEM we are talking about, but we started a project when we have especially the underbody panels and also other components like parcel shelves. And we made, by keeping the same production cycle, so 3-minute cycle, they go from the you can say, semi-consolidated organosheets to the final component with a reduction in weight about 45%. So this, as we were speaking many presentations before, when you speak about cost saving, if you can reduce like 5-6 kilograms per car, just changing the material, ISO process. This is a huge milestone, and also with a reduction of 50% in CO2 emissions with respect to the virgin glass fiber. We then moved to other markets. As I said, we started with the automotive. Then we had the request from like the marine industry. Marine industry needed higher thicknesses, of course, not 2-3 millimeters, but 10, 20, 30 millimeters. So first of all, we started with, we can say, classic, traditional thermoset sandwich panels, nothing special about the process itself. It was glued, of course. the special thing we can say was, of course, the recycled carbon fiber in the skin. Then we decided to move to something more sustainable, of course. So we thought about, we have our production line, thermoplastic production line. We decided to try and to develop this kind of material that we call the Recomb, that actually are made are 100% thermoplastic panels without bonding. They are producing in one shot. So this allows you to save also production cost, of course. And they are 100% recyclable, since it's all thermoplastic, no glue, they're just chemically bonding. They are thermoformable, of course, because we use normally PET, as we were saying today. Everybody was dealing about it. No bonding, as I was saying, so one-shot production and cost reduction, of course, because we can have a production in one shot. It allows you to save to the adhesive phases, etc. As you can see, we compared, of course, to make a comparison. We needed to compare the same core, of course. In this graphic, in this plot, sorry, we are showing the comparison between changing the glass fiber epoxy PET skins with our skin, so keeping the same PET core. We had a reduction about 30% in terms of weight, and up to 35% increase in the mechanical properties. This you can see in the light green is with the traditional, our Recom traditional sandwich panel with a 600 GSM skin instead of a kilo 1000 GSM skin of glass fiber. But if you put the same with the dark green, we put the same weight, as you can see, the mechanical properties are really enhanced, of course. So again, this allows designer, etc., to deal with two scenario: increase in mechanical properties and or both, a decrease in the weight. So you can have a trade-off between. It depends with the application. There are applications that needed more per mechanical properties, keeping the same thicknesses. There were applications that were dealing with just a weight reduction. So we passed from a 20 millimeter glass epoxy to a 10 millimeter with our material, because of course the inertia is compensated by the higher performances of the carbon fiber. So you can have a trade-off, of course. Some application, we are already in the Regina 440 sealing of the FIM, Fabbrica Italiana Motoscafi, EcoRacer 30 of Enel Comp, which is actually one of the probably most famous sustainable sailing team producer, etc. We also moved to the industrial market. So we started with some cooling towers cores, case, and of course also solar panel, etc., for making the case of the panels, etc. And of course we are moving also to the RMV market, so recreation vehicles like caravan and camper. And also in this case, of course, the highlights are a reduction of about 35% in weight. As I said, with a trade-off in the mechanical properties increase up to 30%. And also in this case, a big reduction up to 50% with the CO2 emissions. We have already several customers. We can disclose this customer. We can't disclose somebody else, of course. We have already awards and also collaboration from the university to European community, etc., etc. We were first of all, we were funded in 2022, May 2022. We were almost 2 years old, and we were accelerated by the Motor Valley Accelerator in the beginning. And then we received many awards from the mass media, press, and also the GAC. We won the GAC Italy Startup Booster last year, and we were finalists this year in Paris. And of course, we are also fulfilling different European Union projects, etc., by funding with like the Resist other Eurocluster projects. That's almost all. Thank you, everybody. We are at your disposal for any question you can have. Thank you.
Any question also from the online colleagues?
Yes, when we speak about I suppose the thermoplastic. Yes, we mold it around we just have to activate the material up to the 160 degrees Celsius. Then you can cold stamp, cold molding. So normally that's why normal process is about 3 minutes, because normally you heat it by infrared oven, and then you cold stamp, basically room temperature, we can say. So you put the material up to the 160, then you cold stamp, and you have the component already 3 minutes total around, more or less. Yes, of course. You can add on.
And of course, for the thermoset systems, of course, we can use different matrix. We developed a resin for toolings application for high temperature, transparent, fast curing for press molding, and standard systems for autoclave or something like this. Or in that case, you start as usual. We say for the tooling system, you can use a resin that starts at 55, 60 degree, 55, yes, degree, and later you can go with the standard 120 degree or 180 degree, and the same the fast curing that can be cured at 150 degree 5 minutes, or some application like this. And this is, I would say, in term of thermoset, are quite well known resin system and processes that, of course, we worked to adapt to the recycled material. Our core activity is to offer a complete solution. Then means that we are able to start from the collection of the scraps until the thanks to our partners, not alone, but we start from the help to develop to assist in the collection of the scraps, to select the way to make the first recycle, and then to process and to offer new intermediate product. We can go until the support in the developing new components, depending on the application. No, we have partner that we selected our partner that can give us the complete solution, and you cannot do everything then, but it's really very important to have the complete system.
Sorry, but just to keep it clear, we manage all the chain, so we manage it's all through us, and what we do directly is the production of the intermediate products. That's our manufacturing process. So that's the main business, of course, but we manage also the complete waste chain, of course, also supporting the companies in the end, of course, if needed, not necessarily, but if needed. Thank you.
Yes, we are working on different surface finishes processes in order to grant to the customer different looks or protection. And of course, we are working also with the system for fireproof resistance, etc., in order to be able to approach all the different needs in the markets of the composites.
I just add that, of course, about the nobilization of the material, like with the wood laminates, etc. But also we are working with the welding solution in terms of create bigger panels, of course, without using glues, and again to keep a sustainable solution. Also about the end of life. we were talking more today. We were talking about the end of life boats, etc. Many words are spoken about the different raw material, recycled materials. Yes, of course, you can have 100% recycled material, but if you bond it with a thermoset resin, for example, or adhesive, of course, you will have issues in 20-25 years when you will need to handle the end of life boat. So we are trying to provide also complete thermoplastic solution, also in terms of coupling of our panels, in that case, the sandwich panels. Thank you.
Thank you. So now